All right, so distance. Distance and displacement are two different things. Distance is, let's say this is where I live, this is my house, and this is the store. Here's the park between the two. I'm going to go from my house to the store, and let's say that is 2 miles. Then I'm going to go from the store to the park, and let's say that's 1 mile. My distance that I've traveled, my distance is equal to, well, I went from my house to the store, that's 2 miles, plus to the park, this is 3 miles. But my displacement is really only this distance here. Let's say we were both at the house and I said, I'll meet you at the park. And I didn't tell you I was going to the store. You would think I only went 1 mile because you didn't come with me and know that I went to the store first. So my displacement here is 1 mile. I went from, all you know is that I went from the house to the park. I know that I went 3 miles because I also went to the store first. I just wanted to give you some information about the difference between distance and displacement. So distance can be defined as the difference between point A and point B as a function of time. An example would be that a baseball is hit and falls just shy of home run. The displacement, or the distance above the ground, is the time the ball hits the bat until the ball falls into center field, right? That's the displacement. It can be defined in the following function where y is displacement in feet above the ground and t is the number of seconds since the ball was hit. So they're giving me this formula for distance. If we start with distance, and we saw this on the graph, velocity now is the derivative of distance. So let's say I start here with distance, or displacement actually. I start here with displacement, and I take the derivative. So I'll call this the derivative. Remember, the derivative is the slope of the tangent line, which is y over x. Or if y was miles and x was time, with miles per hour, or feet per minute, or centimeters per second, however you call it, it's still a velocity, okay? So when we take the derivative of the displacement, we get velocity. Velocity can be both positive and negative. For example, if I throw a ball up in the air, while it's going up, it's positive, and as it's coming down, it's negative velocity. Speed is always positive, but velocity can be both positive and negative. Okay, so let's see what it says. Velocity can be defined as how fast an object is going and in what direction. So the plus and minus gives me direction. Velocity can also be defined as an instantaneous rate of change or a derivative. That's what we're saying. In this case, the velocity is how fast the ball is hit and in which direction it travels. When we take the derivative of, let's use some of our derivative rules. So we want to take the derivative with respect of y of t. And the first thing we're going to do is we're going to separate these using the sum and difference rule. I'm going to say this is minus 14t squared. And let's use the prime to say we're going to take the derivative of that plus the derivative of that plus the derivative of that. Now I want to use, I want to use this rule here that says the constant multiplication rule, which means I can take the constant away from the function when I take the derivative and just take the derivative of the f of x part. So what do I mean by that? I'm going to say this is negative 14 times the derivative of t squared plus 23 times the derivative of t plus 2, or the derivative of 2. It doesn't really matter, okay? Now, I want to use my power rule. So my power rule says that if I have x to the n, then the derivative is going to equal n times x to the n minus 1. So now this is going to equal negative 14 times, well, n is 2, so it's 2, my x is t, to the 2 minus 1, which is the first power, so that's that, plus 23, and then we have the derivative of t, which is t to the 1. The derivative is 1 t to the 1 minus 1, which is equal to 1 t to the 0 power, which is 1. So it really just disappears. And if you look on our formula sheet, the derivative of just the variable is equal to 1. And then plus, well, the derivative of a constant, we've also talked about that. And the derivative of a constant is always 0. So if I go here, this just disappears. When I take the derivative of a constant, it just disappears. So I really have plus 0. Now my final answer here is going to be negative 28t plus 23. Let's see if we got it. Negative 28t plus 23. That's the first derivative. The first derivative is my velocity. Now, the next thing we're going to talk about is what is acceleration. So we already said that if we go distance and we take the derivative, we get velocity. But now if we take the derivative of velocity, we get acceleration. How do we get the second derivative? Well, this is my first derivative. Again, I can take out the minus 28. And then I have times t plus 23. And 23 is a constant, so it goes to 0 when I take the derivative. And t, the derivative of t, is 1. So I have minus 28 times 1 plus 0, which equals minus 28. So my acceleration is negative, which means the velocity is decreasing. For example, if I'm in my car and I'm driving, I look at my speedometer. That's my instantaneous velocity, right? But if I have a negative acceleration, it's either because I'm putting my foot on the brake or I've taken my foot off the gas, right? Either one will make me slow down. And that's what negative acceleration does. It slows our velocity down.